What's up, everybody? This is Eddie with FlexCNC, and we are coming at you live from our beautiful facility right here in Wapak, Ohio for yet another amazing demonstration. And per usual, I have a couple of friends with me. Joining me here on my side, we got my man Aaron, our in-house CNC specialist. Aaron, you ready to make some chips today?
Let's do it.
There we go, there we go. And also from our dear friends at Sterling Fabrication Technology, we have the man, the myth, the legend, Jason Parby with us. Jason, how you doing, sir? Hey man, it is well, and it is a great day to be making some chips. So I appreciate you joining us. And before we get started, remember this is an interactive and live engaging stream. So on this part of the screen, you'll notice there is a chat box. Please feel free to leave any comments or questions that you may have. We highly anticipate and encourage each and every one of you to share your feedback. And you never know, you may be lucky enough, we'll be pulling those bad boys up on the screen and answering them in real time. Also on this section of the screen, you'll notice there is a subscribe button. You hit that subscribe button, you hit that bell as well to turn on the notifications so we can keep you in the loop with all the amazing content we're going to be releasing. And last but certainly not least, give us a huge thumbs up. So today we're going to be utilizing our FlexCNC. I have my G Series 2004 machine here. Now this is included a high output package. We're going to be running not one, not two, not three, but 4 different operations on this bad boy. And equipped with it is a ZF gearbox in tandem with a Cat 50 spindle that's going to allow us to get upwards of 368 foot-pounds of torque. And when it comes to capability on this machine, you have the options to mill, drill, tap, chamfer, bevel, countersink, helical mill, and board, all kinds of amazing things. We're going to be showing a lot of awesomeness today. So without further ado, Aaron, what is our first operation today?
Yeah, so over here on the left side of the machine, we got our 4th axis set up with a 2.5-inch tube that we're going to drill some holes in. I know Isaac's going to be running some B-roll while this thing runs. But we got different rotations, and like I said, we're going to be drilling some 9/32 holes into this tube.
There we go, there we go. Let's get things rolling, man. So as we get this set up, we're going to be utilizing our 4th axis. So Aaron, I guess I'm kind of curious about a small little bit of a breakdown while we get it set up. And also Isaac, we got a little bit of B-roll we'd like to show on that 4th axis. So what are we looking at here, Aaron?
Yeah, so right now the setup that we got here, I've got the tailstock that's giving the piece a little bit of support. The part that we're running isn't, anything long or crazy. So as far as needing any support throughout the part, it isn't really necessary. The tailstock is enough to keep that part secure while we're drilling these holes here.
No, it's looking good. And then Jason, got a question for you. So obviously you're familiar with these type of capabilities as well as the 4th axis. So with that, what are some general profiles that you think would work really well in utilizing the 4th axis on a machine like this? Yes, very good, very good. And Aaron, I don't know about you, man, but it looks like this is just absolutely ripping through this part. It looks amazing.
Absolutely. So the drill that I'm using here is a 3-fluted OSG Mega Muscle drill. And Isaac, if you could throw up some B-roll of some other applications that we've utilized the 4th axis on. I'd like to kind of go over the clamping a little bit here. So here you see a really long extrusion. Like Jason had mentioned before, this 4th axis is good for extrusion as well. And what this customer was doing was drilling some holes and milling some slots, but throughout the machine bed, we kind of customized some clamps for them that works well for that particular part, that particular extrusion, just to give the part some support throughout the entire length of the part. But depending on what kind of application you're doing, if you're just doing some drilling, the types of clamps, you don't need anything overly robust. A lot of the force is going down, whereas if you're doing some milling of slots or what have you, you might need a bigger hydraulic vise or clamp like this particular customer was using throughout the part. But that just kind of gives you a good look of one, the different styles that you can, or styles of parts that you can rotate on this 4th axis, as well as, you know, the different clamping that can be involved with it.
No, very good. No, that's interesting to be able to have this type of footage where we can see not only steel being processed in that drilling, but also various types of opportunities in that aluminum as well. Man, I think it's awesome.
Now something else that I can touch on here is, so we have the 3-jaw chuck on the 4th axis right now. So the 3-jaw chuck would be good for really anything round. As you tighten those jaws up, they kind of close together and center up with each other. So as far as finding the center, as that 4th axis is rotating, your part's always going to be in the center line of that 4th axis. If you wanted to get into some tubing or some rectangular tube, a 4-jaw chuck is an option, but that's where you kind of have to think about what kind of clamps that you have throughout the part. That way your part has enough room to make that rotation.
Yeah, no, very, very good point that I think not a lot of people think as much about, you know, because they think we can just easily index change that part over and it's a simple process, but fixturing something we'll definitely get into a little bit later. And so I'm curious, while we're running this part, Aaron, obviously drilling a lot of holes. So is this for any specific application?
This particular application you'll see a lot with customers that are making handrails. We've done a lot of different types and styles, but I'll show a finished part up here. Tiffany will get it in the camera. So here you can see there's just a bunch of holes, and we've had customers that are putting like LED lights throughout handrails or something like of that sort, something that they need to feed something through the entire part from one side of the part to the other out another hole. But this just gives you a little bit of an idea of some of the different applications, I guess, that different customers are using.
No, that looks solid, man. And then Jason, to kind of get you pulled back in. Oh, before we get started, we got a question here. Siva Chamarthi, hey, I like that little pro. Is that the Joker? Nice, nice. So how often do you need to change the drill? But Aaron, would you be able to answer that question?
Yeah, so a lot of it depends on the kind of drill that you're using. I mentioned that we're using the OSG Mega Muscle drill here. It's a very high-powered drill, 3-fluted, and they have actually changed the design of the drill. They added a different coating and changed the geometry a little bit. So instead of it being a Mega Muscle drill, it's actually an ADO TRS drill. But if you're using a high-performance kind of drill like that, I know we've used, we run some cart tops here in-house that we are drilling 200-plus holes on a plate, and you know, we ran over 2,000 holes with one drill, and the drill still looked good.
Wow.
So it's all dependent on what kind of drill you're running and what that drill is meant to do.
No, great question. And if anybody remembers, submit those questions in that chat box. We never know, we might pull those bad boys up and answer in real time. And also, if you feel like, let us know where you're tuning in from. We always love to know where everyone is that's coming in through when they're connecting with us. And then so Jason, to pull you back in here, I know you're very familiar with various types of tube lasers, their functionalities and things along those lines. So knowing the differences between the FlexCNC and the tube laser, how do you feel they stack up in comparison to one another, man?
Yep, sure. Can you guys hear me real quick?
I can hear you.
Okay, I got you. I just had some people message. I didn't know if you guys were able to hear, but I mean, obviously, you know, they're two different tools, but there is a scope of workloads that, you know, there definitely is overlap on. You know, if you're going to be doing a lot of holes like what you're showing right now, or tapping. But, you know, even with some of the lower cost tube lasers, you know, entry-level tube lasers that are coming out on the market right now, you know, frequently that's just the cost prohibitive option for a lot of different companies. But you know, even with the cost, taking that into consideration, you know, there still are a lot of other capabilities, such as being able to machine keyways, flats, you know, countersinks and other things like that, you know, that are really key to the FlexCNC.
No, good points, man. Good points. Because, man, nothing bad to say about tube lasers. There are some credible things that they're able to do, and a lot of amazing applications that we've been able to see tube lasers absolutely just run through and do well. But with the versatility that the FlexCNC brings to the table, it just puts us in a different type of conversation. So that's really, really good feedback. So, Aaron, on this part here, what are we looking at, man? How are things going?
Pretty good. It looks like we just got a couple rows left. But I do kind of want to mention something else that to kind of take off what Jason was saying as far as different applications that the tube lasers are good for. But something that with the FlexCNC that not a lot of people might think about is if you're using a tube laser, and let's say you have to tap those holes after you know the laser were to cut it out. Now that hole is pre-hardened, right? Before you have to tap it. Where if we're able to throw it on the fourth axis and drill it, let's say like flow drilling, we could flow drill the holes on the FlexCNC using the fourth axis, where the workpiece is not going to be hardened, and we can come in and tap it with no problem.
Looks solid, looks solid.
Yep.
Looks like we're coming up maybe on one of the final couple passes of this tube here, is that correct?
Like we got one more row left.
One more row, right on, man. Still ripping through it. So I know you can see it from your camera there, Jason. How are things looking from your perspective, sir?
Looks good. I mean, the looks like you got the processing time and everything on the part looks great, man.
All right, looks like we're just making a couple more passes, have about 2 more rows left on this specific part before we move on to our final piece here. All right. Well, it looks like we have pulled up on the screen. Aaron, you want to go over a little bit of what we're seeing on the controller side?
Yeah, sure. So this is our Delta Tau software that we have on our machines here. You can see I'm in the main tab, which is where you're going to do the majority of the scope of work here. Also, I'm in the auto tab. Anytime you're wanting to run a program, you know, obviously automatically you're going to be in that auto tab. MDI, if I want to manually input some stuff to run automatically, I can do that as well. Move the machine around here in the manual tab. But the nice thing is the editor tab over here on the left. I could bring a program out to the machine, and you know, as I'm walking it through, if I want to make some minor adjustments, having this editor tab where I can make adjustments, use that find and replace application that's in this this window here, really makes changing or manipulating the program very easy.
Oh, very nice, very nice. So is there anything else that we're doing to show the capability of the fourth axis today?
Now, as far as the fourth axis, we're going to keep it short, sweet, to the point.
I like it.
You know, we had some good B-roll up there with some other parts that we have throughout with some other customers.
No, sounds good. No, and obviously it looked like that process time was solid. Finished part looks good. So, question is, what's next, man?
So next up, and obviously you can see we have all kinds of things set up on this machine, which is another great aspect to having a FlexCNC machine. You can throw up many setups. So we have the fourth axis part running up over here. Towards the back of the machine, I have a 4x4 tube that we're going to drill some holes and we're going to make some slots.
And while he's getting that set up, a good point to the fixturing options. A lot of times when you're buying machines along these lines, you have to go and outsource and find other options for fixturing. But on this alone, not only do we have our fourth axis rocking, we have some Kurt vices, as well as some of these pneumatic clamps that are controlled along the bed, as well as some magnetic options that we'll be going to here in the near future. So the options when it comes to fixturing and work holding, I won't say they're endless per se, but you have a various amount of options to be able to do that, and also have a turnkey machine go right into your shop. And while you're getting that loaded up, Aaron, I guess I'm curious, I never asked you this. What's your favorite type of fixturing?
Well, with this magnet fixturing being new to us here,
Yeah.
That's going to be a very interesting aspect that I've never had any experience with. So that'll be interesting, but you know, it all depends for me. What am I doing? You know, the Kurt vices are solid machinist vice that if I'm going to be doing some heavy milling or really any milling at all, your Kurt vice or any machinist vice, that's going to be the route to go. Where the pneumatic vices that you had mentioned, here, you know, I'm doing some drilling and those vices are perfect, especially if this setup particularly is on the back side of the machine. So it's just a simple flip of a switch and that vice closes up. you know, I don't have to be leaning over the machine to put some torque down on that Kurt vise. So I have many likes about many different fixturing options. It's just a matter of what am I going to be doing in that machining process.
Spoken like a true machinist. I expect nothing less, man. I love it. I love it. And so while we got the spindle moving here, what are we seeing? What are we looking at here, Aaron?
So here I got a 9/16 carbide drill that we're just drilling some holes in. And then after this, I'm going to bring in a 1/2-inch solid carbide end mill to contour ramp the slots on the tube here.
Now, and then one more question. So with us using this type of operation, is there a reason why we chose this type of fixturing for this specific operation?
For this particular part, it was just more or less the length of the part.
Understandable.
The milling that I'm going to be doing, because I am doing a contour ramp, I'm not taking like a full depth of cut. I'm not putting a lot of side force on the part itself, which is where the pneumatic vise, as far as compared to the Kurt vise, kind of lacks a little bit in performance. You know, putting a lot of side load, that's not what that vise is meant for. That vise is meant to hold that part while you're putting your down pressure on the part. But because of the, like I said, with the contour ramp that I'm doing with this solid end mill, I'm not doing a lot of side load. I'm just going to be ramping down into the part.
Okay.
Those vices work perfectly for what I'm going to be doing.
Okay. And I feel like I just heard a tool change. So what's happening next for us?
Yep. So here we finished drilling the holes, and now we're grabbing our 1/2-inch end mill to machine the slots.
There we go. So while we're doing some machining on the slots, Jason, let's pull you back in, man. So obviously you're familiar with some of the smaller VMCs. So I'd like to hear your feedback on why somebody would choose the FlexCNC over one of the smaller VMCs out there.
Yeah, sure. Well, I mean, obviously with the name of the machine, I mean, you guys coined that term pretty well. I mean, the machine is very flexible with its open platform. Obviously, you know, you saw with the first part that you guys did over there on your 4th axis, and, you know, operating in pendulum mode, you move on over to, you know, your next zone of machining. So that's really not the flexibility of the machine, the open platform. You can go from one zone to the next, you know, and ease of access. If you got to put big parts in there, you know, just to make sure that you've always got the spindle working and milling and drilling on your parts. But, you know, another big thing too is, you know, even we talk about the zoned machining, you know, for the cost of these machines and everything, you know, it's a very nice economic way to get into a larger format machining center versus some of the large, you know, gantry mills on the market. So, I mean, it kind of lends itself well to somebody who might have, you know, be looking at buying 2 smaller VMCs, but might say, hey, you know, I've got a couple parts that I want to do, versus, you know, another shop where they've just got a lot of, you know, different large parts or weldments that they want to put on it even.
No, good points, man. And I guess to that, another huge benefit that really, when it comes to comparison of this machine versus some of those smaller machines, would be pendulum mode. It's something that really a lot of our current customers absolutely rave about. And then Isaac, when you have a moment, if you could pull up some of the footage that we have of pendulum mode. So what we're looking at here is, you can see you got your operator moves over his safety light curtain so he can actually be able to either place or remove the part while the spindle on his left side is continuing to move. So a big thing really when it comes to this machine is reducing that operation, or whatever it may be, processing time. And so this allows the operator to, one, have that spindle continuously moving on the opposite bed of the machine while he can, again, remove, place different parts. And it doesn't have to be just the same type of part. With the large bed that we have, you have so much access to be able to put numerous parts, whether it's fixturing plates that you have smaller parts that you need to work on, or if you're working on larger parts from side to side. Really, the opportunities are essentially endless depending on the capability that you're looking to do. So, and I would say, maybe Aaron, you can confirm this. So as a machinist, your main goal is that 100% spindle uptime for processing. Is that correct?
Oh, absolutely. You know, the only way you're making money is if you're making chips. So the longer that your spindle's not moving, that's money. That's money that you're losing. So it's huge to have that spindle up and running. It keeps your operator busy. So, as, you know, from a company standpoint, having that spindle up 100% of the time is crucial.
Truly, man. Truly.
Yeah, so I got this part done. Isaac, just because of the parts in the back eddy, I did have Isaac get some B-roll footage of the finished part here, so our viewers can take a good look at it. There you can see the slot and the holes that we drilled there.
Very nice. So Jason, what do you think, man, by what you see?
way to structural steel fabricators. I mean, we see parts like that all the time out there on the market.
No, good feedback, good feedback. So is there anything left in our second operation?
No, the second operation's done. I'm going to go ahead and load up the program for the next part that we got here.
There we go, there we go. So if you don't mind, so briefly, what is our third operation, Aaron?
Third operation is we have a 1/2 by 6 inches long. We're going to be drilling some more holes and then drilling a little bit bigger hole in the center. We have a 3/4 inch drill that we're going to showcase, and then we're going to machine a counterbore on that hole. Something I'll mention before we get into that program is when I made those slots on that last part, I used a solid carbide end mill. And here for this next part, when I machine the counterbore, I'm going to use a high feed mill. So time is going to be crucial. Now, so if you have customers that aren't exactly concerned about the finish of their part, it's more or less just speed. One of the tools that we're going to showcase here, this is where they can really save some time.
There we go, man. Excited to see it.
So the first tool that we're going to pull out here is a 27/64 mega muscle drill. Again, this is kind of like the same style drill that I ran on that 4th axis demo, just a little bit bigger. This would be the size drill that you would use for a 1/2-13 drilled hole, or tapped hole, I'm sorry.
Looks like our good friend Jordan Russell has a question. So max number of tool slots, Cat 40 and Cat 50, and then what's the max length of a tool that can be changed using the tool changer? So let's start off here, Aaron. So we got the max number of tool slots for our Cat 40 spindle as well as our Cat 50. So we're talking about with that, we're looking at 24 tools available on the G series, and then we're looking at 20 as well on the Cat 50. Is that correct? Absolutely. So we got 24 of the Cat 40, and then we got the 20 on the Cat 50. And then Isaac, can you pull that back up? I want to answer that second question. I apologize. So it says, what's the max length of a tool that can be changed using the tool changer? Let me get that for you in 1 second, my man. Looks like we're talking 13 inches of tool this thing can handle. Like a boss.
So Eddie, while you were talking there, we went ahead and drilled the bolt circle pattern with the 27/64 drill. And then the next drill is a 3/4 inch Allied machine and engineering tool. It's a Gen 3 drill. The Gen 3 style drill is very good for high feed rate. And you'll see that here in just a second.
So Aaron, while this is running, is there anything special about this operation that you feel the viewers need to be aware of, or you'd like to at least share?
It's going to be this next tool, really.
Okay.
This is where we're going to get into that high feed mill that I was talking about. And what's nice about the high feed mill is it's a very shallow cut. So you're moving very, very quickly, taking a very light cut. So what I'm going to do is I'm going to helix bore out this counterbore with this tool, and then just come back in with an end mill just to finish it. You know, get it to size or make it look pretty, whatever I need to do. But this is really going to knock it out speed-wise as far as roughing out material.
There you go. And while we have this running, Jason, let's pull you back in, man. So you're obviously a plasma as well as a laser guy. So let's talk about maybe your feelings between the FlexCNC and how it can actually complement the plasma and the laser machine.
Yeah, sure. I mean, like, you know, kind of going back to even like the tube laser that we talked about, there's just a lot of features like, you know, what you guys just showed right there. You know, obviously you can't go do that on a laser, or some of the countersinking and tapping and whatnot. So, you know, if you've got a lot of drilled holes, you know, especially in thicker materials where your pierce times might be a little bit longer, you know, the laser or the plasma is definitely great for blanking out the parts. Or if, you know, you want a nicer hole quality, then, you know, even some of the true hole technology on the plasmas, you know, especially with your Cat 50 ZF gearbox, you know, with, I think you said it was 368 foot-pounds of torque. Yes. I mean, you guys can I mean, the speed of drilling those holes is so much faster than, you know, laser cutting them or plasma cutting them. Or even, you know, let's say if you want to pre-blank some of your parts out of a flat bar, you know, on a saw, I mean, you know, this machine lends itself well to that as well. But, you know, like we talked about, you know, what you're showing right here, additional grooves, keyways, flats, countersinks, bevels, and other things. The machine, you know, just lends itself very well to other methods of processing.
Yeah, no, hey, good feedback, man. And to give you just a quick perspective of a finished part here, we got one here just to, again, show you exactly what we're looking at here so we can see that finish. So what am I looking at, Aaron? Is there anything specific?
Yeah, so these outside holes here were the 27/64 drill that we ran. And then I ran that 3/4 inch Allied Gen 3 drill in the center. And then the 3/4 inch Kyocera high feed mill to rough that material out for the counterbore, and then came back in with that 1/2 inch end mill, just to, like I said, get it to size or make it look pretty. I finished it with that solid carbide end mill.
Man, that's a clean piece there, Aaron. Fantastic, fantastic.
Looks
I love
good,
it.
you guys.
Good deal, good deal. So anything else going on with this specific operation before we move on to the fourth?
Nope, we're moving on.
There we go, there we go. Entering our last, but certainly not least, demo. So what do we have going on, Aaron?
So over here I'm gonna move the monitor over a little bit. Over here on these 3 pneumatic vices, we have a 1/4 inch by 2 inch flat bar, about 36 inches long. Again, we're gonna drill some smaller holes. We're getting some 1/8 inch holes, another 27/64 hole, and then we're gonna put a 1 inch by 3 inch long slot right in the center. And again, I'm gonna utilize that high feed mill so you can really see the speed that comes with that tool.
There you go, good deal, good deal. You know, so much versatility and capability we've been able to showcase today, not only just from the fixturing, but just the different operations. So it's awesome to be able to see all of this shown on one single bed. So that's impressive nonetheless. And one thing I know that, Aaron, I think you could probably speak to this a little bit. It's a challenge, especially if you're just at a fab shop, if you will, and you're not as familiar with doing all the programming and all the back end. So really, what does that process look like for people who think that, oh yeah, you just push a button and it makes a part?
Yeah, so I mean, there's a lot that's involved. You know, from I'll start from the beginning.
Absolutely.
You know, you can't run a part unless you have a program. So the first thing is getting a program, which requires whether I as a programmer draw the model up in Mastercam, which I can, or you know, you'll have engineers that are involved creating a solid model for your programmers to program off of. And then after that, it's taking that solid model into Mastercam, you know, basically it's going to be me telling the machine, what am I going to be doing? What am I going to be doing? Where am I doing it at? What kind of tooling am I going to be using? So once that whole process is done, it's I can then get my G-code program out of Mastercam and put it on a flash drive, bring it out here to the machine, but we're not quite ready to run it yet. You know, I got my program ready, but then it's my fixturing. You know, first of all, it's what kind of fixturing am I going to be using? Am I going to be using my Kurt vices? Am I going to be using pneumatic vices, the 4th axis? But just like you said, Eddie, it's not just throw it up here. It's now I got to indicate things in straight. You know, there's a lot of time that's involved in the setup. So where you have a big machine bed where you can set up multiple parts, you know, even while the machine's running, I can set up a part on the left side of the machine and get it running, come over here to the other side of the machine, get my next part starting to that setup process, and really save a lot of time.
You know, in which I can imagine that process, it seems like it would take a significant amount of time if you didn't know what you're doing, or even if you did know what you're doing, it still seems pretty time extensive. Would you say that's correct?
Oh, absolutely.
Okay, okay. Well, with that being said, we understand that, you know, not everybody's a machinist, and with us trying to make sure we genuflect to a lot of those fab shops, we actually created a program that we're really proud of, and it's called FlexCare. And what it does is it gives us the capability to assist you and really delete the need for you to have to hire a new machinist or retrain your entire staff, because you and I both know that takes time away from them operating the spindle. So a brief intro on FlexCare. It's a membership program that we provide to our FlexCNC customers. And what we're able to do is we're able to bring in our professionals, and we can give you a consultative approach on not only the programming as well as the tooling and the tool paths. We can help you with fixturing, and we can even remote in, take that part, load everything right into the machine, so you have to do nothing other than just run the machine the way that you know how. So for any questions, obviously, please feel reach out to us. And then with that, Jason, so knowing you being so experienced in the field, do you feel like this would be a huge convenience to some of your fabricator customers that really were hesitant to either hire somebody or spend that time training someone up on how to run the machine?
Yeah, I think this is a great plan that you guys are offering. I haven't seen any other companies offering anything like this as far as machining centers go. But yeah, there's definitely a lot of shops, where they say, hey, we'd really like to bring this in-house, but, sometimes finding people, or qualified machinists to, know what they're doing, that can sometimes be a little tough to come by, even with the ease of use in Mastercam and other things like that. But I mean, I think as far as what you guys are offering, that's a great plan. That really is a great stepping stone on helping customers get going to where they're wanting to be at.
No, sure, absolutely. And we've had a lot of customers, even ourselves, just really express to us how much of a time suck that it can be, as well as a resources and investment suck as well. Taking that time to retrain or just train somebody in general, because we understand the fabricators there are fantastic at what they do, but they may have a fear of the machining operation. So offering that FlexCare, it's definitely something that we're proud of. And so we'll shift it back over. So Aaron, what do we got going on here, man?
So here we're going to be drilling our 27/64 drilled holes. There's just one on each side of this part. And then after that, we're going to be getting into the high feed mill again to put the slot in the center of this part.
And so for this specific operation, Aaron, how many tools will we be using?
This particular part, it requires 3 tools, and that all depends on what the customer needs to do with that slot that we're going to put in here in a second. Does it need to be, does the surface finish need to be really good? Does it, what's the tolerance like? The high feed mill, these kinds of tools, the high feed tools are really meant for roughing. I mean, they're there to remove material very quickly. So I'm not overly concerned about the tolerance. If I was, I'd come back in with an end mill and run a finish pass on this part. So what we're doing today is we're just using 3 tools. And I'm sure it's kind of hard to tell for those of you that are watching, but the feeds and speeds that I'm running with this tool, I'm running at 3,050 RPM at 360 inches per minute. So very, very fast, but like I said, I'm taking very light cuts. I did a contour ramp on that slot there, but I only ramped down about 20 thousandths per pass.
Okay.
But that's what those tools are meant for. It's very light cut, and it's very, very fast.
Very nice. So we're getting ready to move on to tool number 3?
That was tool number 3.
That was tool, man, it was that fast. Wow, okay, fast. Wow, there we go. Not surprised, man, not surprised. All right. Are we going to be able to pull that finished part up by chance?
Yeah, I have one.
Got one
right
over here. Good deal. Let's let everybody see what we're looking at. Good deal. Good deal. Here we go.
So as soon as Tiffany can get the camera on it here, yeah. They're kind of hard to see, but I have some 1/8 inch holes that are drilled right here. And then we've got the 27/64 drilled hole right in the center. And then up here, there we go. We got our 1 inch by 3 inch slot there.
There we go. Does it pass the Jason Parvey inspection?
Looks perfect, man.
There we go. No, I dig it. I dig it. So, man, Aaron, what an array of capabilities. And obviously, you've all been able to see a lot of what we're able to do. And then with that, I want to get your opinion. So, Jason, you've seen a lot, and we've obviously shown a handful of things. So, knowing your customer base and knowing your markets, what are a couple of things that you feel really stood out that would be highly beneficial to those who could be in the market for a machine like this?
Well, yeah, I mean, we had, I've got one customer that we've been talking to. I mean, right now he's got some, 12-inch pipe. They're manually doing everything on a drill press. And so you look at some of their labor costs and everything else associated, and you run some numbers and put a spreadsheet together, and one of these machines is a total slam dunk for them. Or you look at some other customers, that are maybe doing structural work or heavy agricultural equipment or other products similar to that. This machine's really a slam dunk. Or the guys who have, some smaller 20 by 40 or by 60 machining centers that really want to get into a bigger machine, but have that flexibility of, the pendulum mode that you showed. This is a great economical stepping stone for getting into that.
No, man, sounds wonderful, and we're highly appreciative of your expertise and your feedback on today's stream. So, Isaac, before we put a pretty red bow on this bad boy, do we have any questions in that comment section? We're good to do. Hey, we got a couple of them, so hey, we thank you all for joining us so much. Jason, is there anything else you want to tell your friends back over there at Sterling or anybody watching today before we head out?
Hey, I appreciate everyone joining us today, and for all the customers joining us on this live stream, and really appreciate you guys having me on today.
Hey, you're a true expert. You're passionate about what you do, and that's exactly why we had you on today. So thank you so much. Thank you all the viewers for joining us. Thank you, Aaron, for being our in-house CNC master and specialist. It's always highly appreciated and always a good time. So before we wrap up today, make sure you hit that subscribe button. You hit that bell to turn on the notifications so we can keep you in the loop with all the amazing content we're going to be releasing. And last but certainly not least, give us a huge thumbs up. I'm Eddie with FlexCNC. You all stay awesome, stay flexing, and we will see you next time.